We got 52 minutes. There's like 4 kids ahead of you, but I'll see what I can do. You could send me lives, and I'll play it.
You could pay him. Pay you to beat you. Probably.
It's almost always Brady.
No, it's Manny.
What's up with those Peyton Manning? Like, who beat this? Who beat this record? Peyton Manning.
Which of these is not a strong ass?
Who looks like
Peyton Manning.
It's probably
Pretty
Brady.
strong.
Unless it's Manny.
Roy Math's always a jerk.
I don't even know who that is, and I've done pretty well in sports, I guess.
That's because they don't make the question. Everyone else.
He's the guy that choked on the Super Bowl.
Warhol.
Your opponent's helping you out.
All right, kids.
You fell. It's for every minute you fell.
Today we're going to do 7.3. General Lee, the name of the card. Basic dude, do over there.
No, this is what after that.
Oh, I would know. So students. Oh, the recent remake. Yeah. So students, you'll need 7.3. Because I think we're done with 7.1. Did we do any of the 7.3 vocab already? No. So the 4 types of coal I'd like to skip. And in the vocab for 7.3, the drawing will be on the board for a while. This is the part where we shift gears. 7.3 vocab. I'd like you to add 3 words.
Is it P?
We did. Beauteous. Next. Number 17, did we talk about the different interpretations of peak oil? And does everybody understand why there would be a reason to politic this? Why some people would like you to believe that there is none left, and other people would like you to believe that there is a ton left? If you think there's none, we can push you into alternative energy. If you think it's endless, we can keep you on the petroleum tip. All right, that's convenient. So then today we start on number 18. And for number 18, I'd like to just remind you of a few things. They are here. Number 18 is like a generic introduction to fossil fuels. I'd like you to add a few things. So first of all, you should think of fossil fuels as an impurity in rock. It's like a stain. Rarely seen. Kind of a fluke of geology in the process of forming sedimentary rock. You, by some coincidence, trap organic material. Please look up. When I say impurities, I usually mean like algae or peat. Like this stuff. That's what becomes fossil fuels. You see, when people think of fossil fuels, they imagine like Tyrannosaurus getting like piled up with like giant squid and aliens. By the way, anybody know how fossils are actually made? Like the Tyrannosaurus fossils? How do they make that? How do we? Yes?
Like stuff they get like buried and stuff, and then the bone like dissolves away, and then something else comes in and fills it in, and makes it look like bone.
Yeah, you could say it's like mold replacement, like bronze replacement statuary.
Yeah.
where the material, like the skeleton, is hard, so when you bury it in rock, all the soft, gushy stuff gets mashed away, and then the skeleton, through chemical changes in the water flowing through over time, will dissolve and get replaced. But yeah, that's how we make fossils. And just so you know, that has nothing to do with fossil fuels. Most of our fossil fuels are much older than the dinosaurs. Most of our fossil fuel goes back to like early life in the ocean, the very beginnings of life on land, way before like the dinosaurs' fossils. Something else I want you to know, please look up, is that fossil fuels are usually a mixture. Coal, oil, and gas tend to occur together. Some ratio. In a petroleum deposit, you'll usually have some coal and some gas. In a gas deposit, you have some coal and some oil. There's usually a blend. Has anybody ever seen when our oil rigs have huge flames on top? That's just getting rid of extra gas. They don't have the plumbing to keep the gas, so they just burn it off. And finally, please look up. A lot of us visualize like a buried whoopee cushion of natural gas, like a huge air pocket of natural gas. Or like a buried water bottle of petroleum, a giant underground reservoir of oil. That's not correct. There's a layer of jumbled together rocks that are slightly porous, like sandstone that you get up at Lizard's Mouth. And those pores will have some blend of fossil fuels in them. But it's almost all rock. With just like this size, pockets of petroleum and gas. I hope you got all those facts. That was number 18. These are the things that will confuse you later on. So now I'd like to move on to number 19 unless somebody has a question. This is like a 3-star study goal. Oh yeah, the energy unit is like 100 million stars. Almost everything, like hours per study. I warned you, it's 5 weeks. Like, there's a lot to talk about here. So number 19 then. I want to talk about all the stuff that doesn't become fossil fuels. Here's what doesn't become fossil fuels. Almost everything. This is a you got to understand that the chances of making fossil fuels on the Earth are exceedingly slim. Probably less than 1 in a million for any bit of organic material. Fossil fuels are like a weird little coincidental accident. Imagine somebody just slapping away at the keyboard and every now and then coming up with like a beautiful sentence. That's fossil fuels. It's like a total, like, how the F did that actually work? Sort of disastrous 1 in a zillion accident. I think everybody understands that organic material is valuable to other life. The entire bottom of the ocean is coated with teeny little scraps of life. And almost every single one of those scraps is going to get recycled back into other living stuff. A worm will get it and crap it out. A crab will eat it and then the crab will get eaten. The current will pick up that stuff and a fish will eat it. it's really important that you remember, organic material stays organic. Biomass remains biomass. It gets moved around, but it stays living stuff. It's actually a really weird set of conditions where you will, first of all, have a layer of organic content and then be able to bury it away from other life forms. That is really rare. Yeah?
So does it ever become anything else than organic material?
99.9% of the time, living stuff stays living stuff. It can break down into gases. It can lithify into some sort of stone. But 99.9, living stuff gets eaten by other living stuff, gets eaten by other living stuff, gets decomposed, and that like food web decomposer recycling thing. But once in a gajillion years, please look up, organic material carried by water into some depositional basin, that's that vocab term I told you to write, a place where sediment deposits. And once in a gajillion years, some weird event will bury it under sediment. These are flukes of geology. Think about it. How often in your lifetime has there been an event that covered up a place like the Santa Barbara Harbor with dozens or hundreds of feet of sand? A, that's never happened in the harbor. B, you probably aren't aware of anything that's happened anywhere on the earth that will bury a lot of organic material with a lot of sand. That's rare. It's probably safe to assume the planet can go a whole century without that happening once. Anywhere on Earth. Fossil fuels are really exceedingly rare. But imagine like an earthquake that causes an underground mudslide. That could do it. An underwater mudslide, I mean. Imagine like a forest fire, and then there's a big old rainstorm, and then you get a big wave of erosion that covers a bay with runoff after a fire. That could do it. Shifting rivers, changes in climate, volcanic activity. The really rare thing that starts this party is this. Not the organic impurities in sediment, but them getting locked up under sediment. Put too deep for the worms and the crabs and the fish to get it. And then, 1 in a million chance, when we've got that fine sediment, then those impurities are locked away, decomposers can't reach them. Now, you just got to wait for enough sediment and enough time to build the heat and pressure that takes all those little carbon atoms and links them all together into a huge carbon chain. And you can call that a fossil fuel deposit now. Yeah?
What does it say with the arrows? It says like sand.
That says 500 meters plus. Anybody want to ask me anything about that? If I was gonna say that fossil fuel formation has one common misconception, most people focus on the organic material. That's all over the planet. The real rare ingredient is that single flush of sediment that somehow buries it enough. Because all the organic material on Earth is on its way to becoming other organic material right now. There's a worm eating it, or a bacterium, or a fungus, or a mold, or somebody's getting to it. So what really makes fossil fuels unique is that giant deposit of sediment that locks them in. Then you just got to wait for enough time, heat, pressure to do the chemistry to make them into fossil fuels. Yeah?
How do we, know that they're there?
You mean like when we have our maps of what's underground? Basically, I think it's leprechauns. Yeah.
So sick.
Yeah.
Really? We find it.
Contrails and
A little bit.
Obama.
No, a little bit.
No, we don't just drill until we find it. I think that most of this is done with like really fancy geological mapping. You know, the conditions for sediment, this is a fact that everybody might want to write down. This tends to occur only at the edges of young tectonic plates. Because you need a certain amount of volcanic activity or tectonic activity to do this. Like in the middle of Kansas, you're probably not going to get the sort of like giant underwater mudslide.
So there has to be like a natural disaster in a way to make this happen.
And those types of disasters tend to happen only at the edges of. So that's one thing. We know that these are found in young tectonic plates. Like geologically speaking, they're pretty young. Because a lot of tectonic plates are older than the fossils that make fossil fuel, right? So young tectonic plates, and usually on the edges, because that's where the volcanic and tectonic activity occur. On top of that, then there's like like radar stuff that they do with sonar to like bounce waves off the ground to see what's down there. And like, I don't know what kind of fancy geology mapping. You go to places that have sedimentary rock that's the right age. So Santa Barbara's a good guess, because we've got like 90-million-year-old sandstone in the hills. So that's like, oh, well, old sedimentary rock, maybe that's the right.
Okay, and then also what would happen, like, I don't know if this is even possible, if like organic material got under the depositional basin?
Got what?
Got underneath the depositional basin. Like, is that even...
I don't know how that would happen, because you're talking about like a giant geological feature. If it had historically, you can get older fossil fuels under younger fossil fuels. That happens. But those are like separated by many millions of years. Yeah.
So what's the case of like Saudi Arabia? Like, why do they have so much oil?
So Saudi Arabia was a low spot in an ocean, and my hunch is that after a period of climate change, there was some massive geological shift that either dried it out and then the wind blew sand on top, or flooded it and a bunch of sediment accumulated over a short period of time. They were just a very significant body of single-celled algae at the bottom of an ocean, and then some geologic shift trapped it. These are good questions. Anybody else want to ask me anything? There you have them. The cap rock, the source rock, and the reservoir rock in the middle. You see that little circle? That's the way you should think about fossil fuels underground. They're like little tiny pockets between big rocks that have the little pieces in there. Yeah.
You were saying earlier how like some in earlier when we were taking out like oil and stuff, and you could just like it would like squirt out and stuff. Would that be like just like a pocket of like? Would that be any different? Like when it's like that, like would it like how it's underneath?
No, it wouldn't. It wouldn't be any different. I think most of us had this, like, before I actually thought about this, the vision I had without really articulating it was that there are these, like, giant underground reservoirs, like big buried propane tanks or something, that are just like these giant cavernous, like, underground seas of petroleum. And that never exists. That cannot form. There is like rock that got squeezed and the organic stuff squirted upward like stepping on a mustard sandwich. Like it just kind of like squirted through and then more sediment formed on top of that and then it just kind of hardened. So they're just like mustard stains in a squeezed sandwich. This is actually how the nuts and bolts would work. You've got the source rock, which is the organic rich soil that gets buried. When it gets buried, the organics push through. And so the source is where the organic stuff came from. It gets forced into the porous stuff, and that gets buried under some fine stuff. It's like a fluke, and then these like details and you know when people say like, oh yeah, sure, you can go to college, but you got to jump through all these hoops, and then you still might not make it, and then your chances are really bad, and then you got to pay for it, but sure, you can go to college. Like that's how we make fossil fuels. It's like all the right things have to line up, and then you got to get the right order of random sediments, and then you got to wait a really long time. Yeah.
How does I don't know the term for it, but how does the fossil fuel, how do they get migrated upward?
They don't necessarily, other than pressure squeeze. You mean out of the source rock?
Yeah.
That's just pressure.
Oh.
So like if you had wet socks and you stand up, that water pushes through your toes. Yeah.
Could we set this up artificially? Like in landfills, so one day it'll turn into oil?
It's a really good question. I don't know. I would imagine so. I would think if it takes any effort, it might be sort of silly because we're talking about a future so distant that it's almost certain humans wouldn't be here to benefit from it. But you weren't asking about the strategy. I'll bet you somebody knows enough details that they can set it up. Yeah. I think it would be an astronomical effort, but yeah, it must be humanly possible. It would be pretty large-scale geoengineering, I'll tell you that. But arguably the bottoms of some reservoirs, like dams, if you could keep those dams from breaking, which is their obvious geological flaw over time, if you could keep the dams from breaking, a lot of those sediment layers probably have the right mix for this. Now, just so you know, I'm not going to start any drilling here. You're smiling because you're digging.
Yeah.
Did you win already?
I have one more.
One more. And it's still your turn?
No, it's your turn.
Just so you know, I'm not going to start drilling yet. In the Santa Barbara Channel, for example, sometimes that stuff comes out on its own. You guys all know that seepage where you walk at the beach and you step on oil? Everybody blames the rigs for that. The rigs probably have very little, if any, interaction. Do you know that the Santa Barbara Channel is the second leakiest planetary crust on Earth? There's only one place where there's more natural seepage, and that's in the Caspian Sea. What happens is, sometimes, that cap rock is not perfectly monolithic. So in the Santa Barbara Channel, our cap rock is kind of thin and brittle. We're on an earthquake fault. So as these plates adjust their pressure, little cracks under the ocean let petroleum seep out. It's under a ton of pressure, hundreds of feet of water plus hundreds of feet of rock. So whenever you can crack the cap rock, it comes out on its own. That's natural seepage. Everybody got that? Because humans know that petroleum comes leaking out of the crust sometimes, we figured out maybe we can just make a hole in that cap rock and let it out. This is some hardcore note-taking you got to do. There are 3 basic petroleum extraction methods. Oh yeah, this unit is 20 pages of notes, just saying. This extraction comes in 3 phases. The easy stuff, please look up, is called primary. The one that's kind of difficult, takes work, is secondary and tertiary extraction. It's only worth it if you can get paid enough money to cover all the energy costs. A lot of times tertiary extraction doesn't happen. So here we go. When you can break that crust, primary extraction is the easy stuff. Then you reach a threshold where you got to start doing work. Then you reach a threshold where you got to start doing really hard work. They're called the three phases: primary, secondary, tertiary extraction. Primary is the easy stuff. Like popping the zit, it comes out under its own pressure. Yeah, but this says you haven't finished your turn yet. And notice, that's just a little tiny bit of the petroleum. On average, 5 to 15% of the juice. I'd like everybody to visualize something, please. You got a sheet of plywood, a bunch of rocks, and a sheet of plywood. Something changes, you let out some pressure, those rocks will shift a little bit, and then you're just back to plywood on rocks with plywood underneath. Watch me. If you've got plywood, and rocks, after a little shifting, they're going to be on rocks again. Everybody understand that? So after you've let out the petroleum, there's just a little adjustment of pressure, and then you're back to rocks on rocks. So that, please look up, is a small percentage of the total petroleum, 5 to 15% of the total deposit. It's not very much. And up until the 1930s or 40s, that's where we stopped. That's all we could get. Later on, people figured out what the well... Anybody know what wells do? Like after it comes out under its own pressure, what's the well going to do? It's going to what?
Put more pressure back in.
What is it?
Put more pressure back in.
Right. They are not sucking out petroleum. They're pushing water down so the petroleum will float its way up. They're adding pressure to squeeze the petroleum out.
Is that the thing? Is that on the freeway? It's like the...
Yes. Those,
Yeah.
they're not sucking out. They're pumping in. They do work on the downstroke. That's called secondary extraction. Please notice that number. We're still just getting a little bit of the petroleum down there. When we start pushing, most of the petroleum is still stuck between rocks. So when you push, that's just going to squeeze the petroleum that's basically in a continuous oil channel all the way to the extraction pipe. That's the only way that that water can escape, is when it pushes petroleum. That's the only petroleum you're going to get. So still we've left the majority of the oil down there, right? You had 5 to 15 before, now 15 to 30. We're somewhere between 20 and 40% extraction. Agree with me? Anybody know how you could get even more out of there? Yeah?
I'm not answering that, but 15 to 30, is that like in addition to the other 5
Yes.
to 15?
Yes. How do we get more out now? We've pumped stuff down there to like push the petroleum around. Now what? How do we get any more?
Now do we start trying to like suck it up?
No, suction doesn't make any sense because everything is encased in rock. So, you know, like trying to suck the air out of a glass bottle with no air replacement, it would be impossible.
Try sucking it out and putting air in at the same time.
There is technically, okay, so extraction wells do have a little suction. Truth is, yeah, they do have a little suction. But you can't really, that distance you would deform the pipes and stuff. Suction, yeah.
Wait, so if you're pushing, like with the wells pushing that material back in to seal it, how does it like push it, the oil towards the wells? I thought the wells weren't extracting. Like how
So the ones are like opening up, usually they have like a flat valve. So as you add pressure, this one can let out some of that pressure before it comes up.
So how far away do you think those are? Like,
Oh, they're sometimes right, literally like next to each other, and sometimes miles apart, 3-5 miles apart, maybe more. Depends on the deposit. Anybody else? How would we get more out? I love it that some nerd figured this out. None of you have figured it out? What if we could heat up the remaining petroleum? Make it runnier. So we add steam or chemicals. Oh yeah, it's very dangerous. That's why it's not cheap. So you make the remaining petroleum a little bit runnier. But the concept that I really want you guys to adopt here is that most of the petroleum stays down there. Because it's in rocks, between rocks, underground, there's not much you can do to take it all out.
what's viscosity?
Viscosity is runniness. So to increase viscosity means to make it more runny.
It was thicker before.
It was thicker before. It's really cold underground. That petroleum is kind of like tar consistency. Yeah,
So at most you only get 60% of the petroleum.
and that would be extreme extraction. That's super rare. My hunch is the average for an American well life is maybe 30-40%. And then we shut them down. You know, there was a time when Obama was battling Mitt Romney during a debate. And I believe Mitt Romney said, I support American energy independence. That's why I believe we should give American petroleum companies access to these 7 things that I've put on my list. And Obama was like, whoosh. Those 7 things would add like 5 gallons. I just encourage American energy companies to take more out of the other ones they already have. They could get a bazillion gallons out of that. And the concept was, let's just keep getting more out of the ones that we currently use.
So,
Yeah.
so like when you decrease the runniness, does that just make it easier to
You increase runniness. Okay, so viscosity is the opposite of runniness. Viscosity is
Oh, you
goofiness.
said it was decreased.
Sorry, the concept is runniness. Sorry.
Okay.
Yeah. So here we're injecting steam that becomes water that makes the petroleum runnier, makes it more juicy. And this is what those networks look like. Somebody was asking me how far apart are they. Well, it's basically a combination of all these things. You find the thin spot in the crust and let the petroleum out. Then you go to a couple other places and you add pressure to chase the petroleum out. Then you find the thin spot and you add steam so that it stays runny through the squeezy point. So when you guys go to Arco Island, do you guys know Arco Island? Down near Carp? What's the other name for it?
Like the bridge going to it?
Yeah, that little bridge going out by Little Rincon, between Rincon and Little Rincon.
Oh, with fig palms?
With the fake palm trees, right. How many of you saw those fake, know that there's fake palm trees? You drive by and they look like palm trees, when you go past them, there's like a sheet of plywood. Those are the best.
I thought that was Hawaii.
How cute. It's not Hawaii. Okay. Anyway, that island is that rig in this diagram. And when you're driving by, everybody wants to see the palm tree thing, but you should try looking the other way. And there's a point where you go like past these two canyons and you can see down canyon. And if you look back there at night, there's like a field of lights and all these wells and all these rigs and stuff. There's this whole network of injection and extraction and steam generation, and they burn off natural gas. And then they use that heat from the natural gas to make more steam that they can inject down. So whenever they get pockets of natural gas, they burn it off, and that increases the viscosity in this one little section so that more, or decrease, whatever, so that more stuff comes through. Super neat. It's really complicated. It takes a long time. That's why these rigs, these wells take like 30, 50, 70 years to be fully extracted. Because you got to do all the mapping and figure out where the challenge is now and see if you can go add steam or add pressure or whatever. Yeah, bro.
So when you're on the freeway down there, like you see like there's like this like fire.
Yeah.
It's just that natural gas.
Yep. Apparently that's a place where the plumbing doesn't work to move the natural gas. And because natural gas is explosive and toxic, you don't want to just let it like bubble around the facility where all the workers are next to the freeway. And so I believe that the federal government forces them to burn off all their natural gas. What else did I want to say about this? I'll probably remember later. So now think about this crazy thought. We've left a lot down there. I think somebody did the math over there. And in the best case scenario, you're leaving 45%, but usually you leave more than half. Now, I want everybody to notice something. Please look up. Over here, please. I'll leave that on there, but look over here. This stuff is drilling a hole in the ground, the petroleum comes squirting out. That's pretty cheap, right? You drill the holes and you catch the petroleum. You ever know what I mean by that? But now, what happens when that's done? The petroleum companies are like, well, that was the easy money. Let's go drill another hole. But obviously, if you can build pressure, you'll get more. But now you got to start doing work. All those rigs, they run on petroleum. Everybody understands that, right? They're either powered by natural gas or crude petroleum or refined petroleum or gasoline or diesel or something. So all those rigs that are doing all that work, that costs petroleum. So exactly, they might have to take 2 barrels out of the ground, but one of them is to get the next barrel, right? So all of a sudden, please look up, this is really profitable. This is like marginally profitable. And this, making steam and all the fancy plumbing to keep steam pressurized, Like if you're an engineer, you know it's really hard to work with steam. Keep it hot, keep it under pressure. That's really tricky stuff. So this is only done when petroleum is at extremely high barrel prices. Now that petroleum is at like a 10-year low, I'll bet you there's no well in the country doing, anywhere in the world doing this. You just can't afford it. It's too many dollars. Nobody wants to spend $70 to make a barrel of petroleum you sell for $38. You know what I mean by that? So this is what the petroleum companies always want, because that's the easy stuff. That's always profitable. This is like, usually profitable because people are willing to pay for it. This is like, dang, I don't even want to get into that. It's usually a losing proposition. We're just hoping that it'll be expensive enough that I can make that pay off. Yeah?
How do oil rigs work? Like, how do they apply the pressure and do
I have no clue. Yeah. Something to do with leprechauns, I know. I'm sure of that. That part. Quote me on that. Ewoks.
Where's spent
Unicorn
deposits?
farts.
Spent deposits is petroleum where like, I think we're done, right? 'Cause we can't get any more of that. Can we do $1,000? No, it's not worth it. We can't get any more. That's a spent deposit. Or people walk away. And they do walk away. Anybody here live on the Mesa? You ever drive by the main entrance to Monroe?
Yeah.
Do you remember last year when literally right next door to the main entrance to Monroe, like the house next to the driveway for Monroe, they had a huge container parked out front and a rig on top of a lady's house for a couple of months? Most people never noticed that. This is at the intersection of Cliff and Flora Vista looking out to the ocean in the year 1929. The road you see going from left to right, that's Cliff Drive. And off into the distance, you can see like a little staggered intersection. See that staggered intersection? Those of you who know the Mesa, that's where Flora Vista, almost but not quite, runs into Mesa Lane down to the steps. There it is. You see that staggered intersection from the foreground to the background of the photo? So, an oil rig over here was abandoned sometime in the 30s. People built houses. All of these are not covered up with houses, right? Everybody knows these are all covered up with houses, right? And apparently, there must have still been a little tiny crack in the crust that was letting petroleum out. Because last year, or maybe 2 years ago, a plumber shows up at this lady's house and she's like, my plumbing's not working right. And the guy goes to look inside her and he goes, that's because you've got petroleum coming out of your foundation. So somebody figured out the mineral rights and all that crap, and they called up some company. That company's like, fine. And so they came out and they punched a hole through that lady's roof, all the way through her foundation, made a well casing, released all of that petroleum under pressure. It's not a big enough volume to actually bother filtering and packaging it and selling it. So they used to fill up those Marburg containers. They literally spread out a rubberized tarp and filled Marburg containers with petroleum, and then they just took them to some waste disposal site. Then they had to fix her kitchen, and so she got a new kitchen out of that. She knows my wife, so she was super stoked on getting a new kitchen. It's like, yeah, we had to live somewhere else for 6 months, but I got a new kitchen.
Pretty sure that's bullshit. Petroleum can't be sold.
We do abandon them. Check this out. I know a lot of you can't read from the back, so I'll show you what all the debate about petroleum is. This is the United States. These numbers could have shifted a little bit because this is probably a 10-year-old slide by now. So you might find more recent slides, but here comes your content. The biggest glob, more than half of America's petroleum, is already abandoned. We've plugged the plug, built a fence, moved on. Or we've sold it and people built their house or whatever. That's the yellow, brown, baby diarrhea color. And up there, that's all the stuff where we are producing. That's the orange. That's like the stuff that we're actively getting right now. Now look at the little slices. That's what we're still fighting about in America. What we're fighting about in America is the dark blue, where we know it's down there, but we haven't gotten it yet. Or the light blue, the stuff that we could use that we could get with today's technology, we just haven't put on the map yet, that we figure we haven't discovered yet.
So
That's
like
the mystery percentage.
It's like an estimate.
Yeah, it's an estimate, right, because we haven't found it, obviously. And then that olive color, that's the estimate of what we still haven't found, but we know we wouldn't be able to get. So the future of American drilling is basically the dark blue and the light blue. Dark blue, we know where it is. Light blue, we hope we'll find it. When people talk about, is it peak oil or is it not peak oil, remember that a lot of that kind of is just a question of how much we're willing to spend to get it. But a lot of our petroleum we've already walked away from. It's underneath the mesa, for example. So it's like, oh, there's plenty of petroleum left out there. Like, yeah, but don't blame Obama, or don't blame me, or don't blame the environmentalists. Like, how the hell are you going to get it out from underneath the mesa? Anybody want to talk more petroleum? Because if not, I'm going to leave fracking for another day. No more? On your marks, get set, trivia quiz.